wanted to talk about the commutative property and the fact that division is not commutative. So the commutative property is when we can add two objects and regardless of order get the same thing. So when we're talking about commutative, I want you to think of the word order. Does the order in which we add things matter? So if I have a plus b, I know that for real numbers a and b, if I add two elements, a and b, I'll get the same thing if I add them in the reverse order. So the commutative property works for addition, and it also works for multiplication. If I multiply a times b, I'll get the same thing I'll get if I multiply b times a. In other words, the order of multiplication doesn't matter. But when we're talking about subtraction and division, they are not commutative in general. So a minus b in general is not the same thing as b minus a, and a divided by b in general is not the same thing as b divided by a. When we talk about subtraction and division, order matters. So this would not be true unless a is actually equal to b or a is equal to negative b. So I'll give you a quick example. Let's say we have 4 divided by 2. Is that the same thing as what we would get if we reverse the order of division? Well, 4 divided by 2 is going to give me 2. But 2 divided by 4, I can simplify that to give me the fraction 1/2. And since 2 is not equal to 1/2, that's one of the examples where division is shown to not be commutative. But if they were the same number, let's say I had 5 divided by 5, that would be the same thing as if I reversed the order and did 5 divided by 5. I would still get the same quotient, 1. So in that case, if we have the same numbers on the top and bottom, or if one is a negative of the other, they have opposite signs, then that means that division may be commutative there. So if I had 5 divided by negative 5, I would get the same thing as if I reversed the order and put negative 5 on top and positive 5 on the bottom. I would still get negative 1 is equal to negative 1.